Hi friends. Welcome to AICTE Internship on AI, Transformative Learning with TechCiem, a joint CSR initiative of Microsoft and SAP. Now we're going to explore an exciting topic: implementation of a machine learning model for image classification. Course outline. Here's what we'll be covering today. Problem statement. We'll start by understanding the challenge of image classification. Proposed solution. Then, we'll explore the machine learning deep learning approach to solving it. Software requirement. I'll outline the software tools needed for the project. System architecture. We'll take a look at how the system is structured. Video of the project. I'll show a quick demo of the project in action. Applications. We'll discuss real-world uses of image classification. Future scope. I'll highlight possible future improvements. Conclusion. Finally, we'll wrap things up with key takeaways. Problem statement. Let's think about the challenges of classifying images manually. It's time-consuming, prone to mistakes, and costly, especially with large data sets. Visual data, like images, often has complex patterns and textures that are hard for humans to interpret consistently. For businesses that need to process huge volumes of images, manual classification just isn't practical. Plus, extracting useful insights from unstructured image data for analytics can be really difficult. These are the key issues we'll aim to solve with machine learning or deep learning. Proposed solution. Here's the solution we are proposing for image classification. First, we start by collecting a large, diverse set of labeled images. Then, we pre-process the images through steps like data augmentation, normalization, and resizing, which helps keep the data consistent and improve the model's performance. For the actual classification, we'll use a convolutional neural network, CNN, which is great at recognizing patterns in images. We can also take advantage of pre-trained models to save time and boost accuracy. This combination of careful data preparation and CNN models forms the core of our approach. Software requirements. Let's go over the software requirements for our project. Front end. We'll use Streamlit Web Config to create an interactive user interface. Backend. The backend will be powered by Streamlit API and Python for handling data and model integration. Model. We'll implement a convolutional neural network, CNN, for image classification. Framework. We leverage sklearn for data handling and TensorFlow for building and training the model. Deployment. Finally, we'll deploy the application using Streamlit Cloud for easy accessibility. These tools work together to make our system functional and user-friendly. System architecture. Let's walk through the system architecture. Input block. This is where we receive the images to be classified. Data collection and preprocessing block. Here, we gather the images and apply preprocessing like resizing and normalization. Model selection and data split block. In this step, we choose the appropriate model and split the data into training and testing sets. Training and validation block. The model is trained on the data and validated to ensure accuracy. Evaluation and optimization block. We evaluate the model's performance and fine-tune it for better results. Deployment block. Finally, the trained model is deployed for real-time image classification. Each block plays a crucial role in building an effective system. Mobile Net2 pre-trained model. Let's talk about the Mobile Net2 model. It's trained on the ImageNet dataset, which allows it to classify images into 1000 different categories. Now, here are some common image types it can work with. Natural images. Photos of things like animals, landscapes, and people. Product images. Items like clothing, electronics, and furniture. Food images. Different types of food images for recognition. Art images. artworks such as paintings and sculptures, medical images, medical visuals, like X-rays and MRIs, for specialized use. This model is highly versatile across various image types. Project planning and data preparation. In this first phase, we focus on planning and setting the foundation for our project. Define the problem and objectives. We start by clearly identifying the image classification problem and setting our goals for solving it. Set success metrics. Next, we determine how to measure our success, like accuracy or images correctly classified rate. Gather requirements. This is where we list everything we need: software, data, and tools. Create timeline. Finally, we set a timeline with key milestones to make sure we stay on track throughout the project. In this second phase, we focus on gathering and preparing our data. Collect data. First, we gather the image data we'll use for training the model. Clean data. Then, we apply pre-processing like resizing and normalization. Transform data. After cleaning, we process the data to get it into a form that's ready for analysis. Feature engineering and data split. Finally, we extract important features from the data and split it into training and testing sets to build and evaluate our model. Model development and deployment. In this third phase, we focus on building and assessing our machine learning models. Select models. We start by choosing different machine learning models that are suitable for image classification. Train models. Next, we train these models using our training data so they can learn to classify images. Evaluate models. After training, we evaluate how well the models perform using our testing data, checking for accuracy and effectiveness. Refine models. Finally, we refine and tweak the models based on their performance to improve their accuracy and reliability. In this final phase, we focus on putting our models into action and keeping track of their performance. Deploy models. First, we deploy the trained models to a production environment where they can start classifying incoming images. Test and monitor. Next, we test the deployed models in real time and continuously monitor their performance to ensure they're working effectively. Maintain and update. Over time, we may need to maintain and update the models to adapt to new images they remain accurate. Document results. Finally, we document the results and findings from our project for future reference and improvements.
Hello everyone. Let's talk about the projects. This project is image classifications using deep learning neural networks. So let's talk about the file first. So this is the train.py where we are using the CIFAR10 datasets. The CIFAR10 datasets has images from 10 different categories. So here we are doing the pre-processing task. As we are working on the images, we need to work on the CNN. So this is the CNN models. We have a 2 convolutions layer. After that, we have a train our data and we have stored this model with the .h5 file. Okay. Now app.py, this is the main file where for creating UI I have used Streamlit. This is the main functions where we have 2 choices. Okay. So the first one is a MobileNet V2, that is pre-trained model. Second one is a CIFAR10, which we have trained by ourselves. Let me expand these functions. So here we need to upload the images. Okay, and it will use the CNN models which we have trained, and after that it will make a predictions. We are also displaying the prediction class along with the confidence. Now let me show you the demo. So this is my GitHub repository where you will find all the commands for downloading the repo creating the environment variables, installing the dependencies, and then we can run the application on your system. I have deployed these projects and this is my URLs. Let me just show you the first image classification model, that is CFAR10. So here we have a different images. Let me put the horse image. So image is being uploaded and here you can see that is the prediction class is a horse. Okay, I can use the different images as well. We have a truck images, okay, and it will be classified correctly. Now let's talk about the another model, that is the MobileNet V2, which is pre-trained models. Okay, and we can use different images for that purpose. So let me put this image. Yes, so it is classifying the rocking chair with their confidence. Let me try with one more images. Okay, so it is correctly classified into television. So this is how you can create a image classification using the CNN convolutional neural network, as well as you can use pre-trained models, which is MobileNet V2. Thank you.
Applications. Now, let's explore some key applications of our image classification system. Object recognition. It can identify specific objects in images, like cars, airplanes, cats, and dogs. Image search. This allows us to find similar images based on visual content, which is useful for search engines. Medical image analysis. It helps classify medical images, such as X-rays or MRIs, to assist doctors in diagnosis. Content-based image retrieval. This system retrieves images by analyzing their visual features, not just metadata. Image captioning. It can generate descriptive text for images, making them easier to interpret. These applications show how powerful and versatile image classification can be. Future scope. Looking ahead, here are some exciting possibilities for improving our system. Fine-tuning and transfer learning. We can boost model performance by fine-tuning it with specialized datasets or using transfer learning with diverse datasets. Integration of additional models. We could add more pre-trained models like ResNet, VGG, or EfficientNet to improve accuracy across different image types. Custom dataset support. In the future, users could upload and train models with their own datasets, making the system applicable to various industries. These upgrades can expand the power and flexibility of our image classification system. Conclusion. This image classification project has successfully combined advanced deep learning models into a user-friendly platform. We've shown how it can be useful not just for educational purposes but also for real-world applications. The project has demonstrated its ability to provide real-time insights and deepen our understanding of image classification techniques. Looking ahead, we plan to continue evolving the system with model improvements, broader dataset support, and even more advanced features. The future is bright for this project, with plenty of room for growth and innovation.